Hello, everyone. Good afternoon. So, how are you? I hope that you have already taken your lunch, okay, and is ready to today. Okay, okay. So, I'm sharing this right now. Do you all can see the slide or not? You all can see the slide or not? Can you all see the slide? I mean the screen in here. I mean the presentation slide, not as the this one. I'm not sure whether I'm sharing the correct things or not. Share your screen. Entire screen. No screen. Oh, okay. Okay, now this is correct. Okay. Okay. So, hello everybody. So, hope that you all are doing well in here. So, it's another day where we are going to talk about answering technique for semester 2. Okay. So I hope that you're ready for this. Okay, so without further ado, shall we begin? Okay, so as usual, let's go to a little bit of self-introductions in here. Okay, so let's move on. Okay, so as you already know, I'm Mr. Chu, so I hope that you have already know me already. We have been together since semester 1. Now we are in semester 2 already. So a little bit origins to those who don't know me. I'm Mr. Chu, currently 43 years old, now teaching in SMK Tasik Utara, Johor Bahru. I've been teaching 21 years already, how time flies. Okay, and hopefully for more years to come, right? Okay, so let's move on to the next one. Okay, so teaching experience, I've been teaching 20 years already. I'm ex-national trainer, presenter, authors of this Absolute Guide. And then last time you have these LP books, okay, which you can find. And I not recently see that in Shopee also they have this soft copy. I don't know, but it's not me who's selling. If Mr. Chu sells one, it's definitely the original copy. But how to put in words? I don't know whether it's a good thing for them to do that or not. So if you purchase from them, I don't know, because they sell in a very cheap price. Might as well you ask from me, I give you for free. So that you don't have to buy from them. Okay, I can share, never mind one. Okay, I believe some of your teachers also they have. Also ask from your teachers. Okay, don't buy online. Support original. Okay, so then let's go to the content, shall we? Okay, so today we are going to talk about the scheme of assessment first. Even though we have already go through a few times already, but still I would like to highlight a few things that I feel that you all need to know as a STPM students. Okay, where in here you have to know that okay. This is the point. Okay, so you have already seen in semester 1. Okay, you have already seen in semester 1. Now you are in semester 2 already. So it is still the same 15 objective, 2 structure, 2 essay. And then throughout our talks, I will try my best to guide you on how to how to answer in the best way, because most of you, I figure out that even my own school students, they are still very weak in time management now. Because STPM, you must be very fast, you see. You cannot afford to really waste a lot of time here and there. So that is why it is important for you to learn the time management for how to answer the STPM. So I will share my experience with all of you if I can, and hopefully you'll be benefits from it. Okay. Oh, okay. I'm running out of battery already. I also don't have battery. Oh God, why is this happening? Okay, never mind lah. Okay, so okay, never mind. Okay, so let's continue. Okay. Okay, so we go to the next one. Okay, so this is what you can do. So make sure that you read in details all the possible and create your own short notes based on your understanding and check with your teachers or reference book or online sources. I already shared with you, isn't it, the short notes of the semester 2, and if you buy my module, I also have short notes, isn't it? So my short notes is definitely not 100%, but it will cover at least 60-70% of the content in here. Okay, so I hope that you'll be able to create your own short notes and write your own ideas based on it. Okay, so you must also do STPM past year question. So far in STPM semester 2, we have a total of 22 set from 2013 until 2023. So total is 22 set. In my school, I remember force all my students to do all the 22 sets. So, and that is what we are discussing right now. And hopefully you all will be able to understand accordingly. All right. Thank you very much, EC. Okay, and then do a study group with your friends. So a study group actually is the best way to study. So sometimes it's very hard to study alone. And then when you share the knowledge with each other, you'll be able to actually catch better, isn't it? Okay, so I hope that you'll be able to understand how to study in group. Okay, so even if you go to university later, you still need it. All right. Okay, so shall we go on to the main component of our talks today? So I hope that you have already solved the questions that I pre-prepared for you before our talks today. So yeah, without further ado, let's begin. So the answer you can see from the YouTube link down there, and then I also forwarded to your school teachers, I believe. I think I forwarded to your school teacher, and most of you have already this one. So I hope that you have already have the answer with you. Do you all have the answer already? Okay. Okay. So hopefully you have the answer with you already. Okay. So without further ado, let's begin our discussion of the past year of the questions. So we shall begin with the section A. So you have to answer all the questions in this section. So in here, if you look at this one, is 15 mark, 15 mark, 30 marks. Okay. So if you have 15 mark in part A, 15 mark in part B, then 30 mark in part C. So you should be divided equally into 15 marks in here. Okay. I don't know how to write in the second screen. So that is why it's a little bit like handicapped when I do that. Okay. Okay, never mind. Okay, so yeah. Okay. So you should be able to divide the time equally. Section A, 20 minutes. Section B, 20 minutes. Section B can even shorter actually. And then section C, 25 because it's essay. You need more time to write. Okay. So you must be very good in your time management. And I hope that you really train for that. Okay. All right. So without further ado, let's together begin our discussion for the questions, shall we? Okay. So let's start from question number 1. The following are some chemical equation carried out under standard condition. Which of the following equation are exothermic? Okay, so let's together understand one by one what does each of these enthalpy change represent. So number 1, Mg solid plus half O2 give MgO. This is a what? It can be two. It can be formation, and it also can be combustion of the oxygen. So it is an exothermic reaction. Okay. Okay, and then the second one is O minus plus E minus give O2 minus. This is second electron affinity. So second electron affinity is an endothermic process. So it is endothermic. And then number 3, you have Mg2 plus to Mg aqueous. So this is enthalpy change of hydration. So enthalpy change of hydration is exothermic. And then last but not least is MgO give Mg2 plus gas plus O2 minus. This is a reverse of lattice energy. So reverse of lattice energy will make it to become endo. So in here, which one is exo? Number 1 and number 3 are exothermic. Therefore, the answer is C. Okay. Okay. So can understand? Any questions? So in here, students, you have to be familiarized. That is why I said that you need to memorize all the 10 enthalpy change. We have 10 enthalpy change. What are the 10 enthalpy change that we are talking about? Number 1, you have formation, combustion, neutralization, atomization, bond energy, ionization energy, electron affinity, lattice energy, hydration, and solution. So you have 10 enthalpy change that you must be able to familiarize with, so that you'll be able to answer accordingly. Okay, so hopefully when you are asked to questions of how to answer it, so you'll be able to know this process is endo or exo. Okay, so that's why I said short notes is important for you to identify this. Okay. All right, so that is for question number 1. Immediately we go to question number 2, shall we? So nitrogen monoxide is formed through rapid heating and cooling of the gases in the atmosphere within a lightning bolt. So you have half N2 plus half O2 give NO. So delta H is positive 91 kilojoule per mole. Standard enthalpy of atomization of N2 and O2 are positive 473 and positive 249 kilojoule per mole respectively. What can be deduced from the information in here? Okay, so before we go into the detail, let's have a look at how to calculate the bond energy or the atomization of nitrogen monoxide, shall we? Okay, so from the equation, we have half N2. This is the atomization now. So you have half N2 give N gas. So this is the standard enthalpy change of atomization for nitrogen. And then you have half O2 give O. This is the standard enthalpy change of atomization for oxygen. And then you have the formation as given to you earlier, half N2 plus half O2 give NO. So because now you want to find bond energy, isn't it? So the bond energy in here, or atomization, actually these are two same things. So it is NO give N gas plus O gas. So delta H of atomization is positive 631 kilojoule per mole. So in here, D is automatically wrong. Okay, so it's in here. So for here, as you can see, the enthalpy change of the reaction is the endothermic. So that means equilibrium does not favor to the right. You must always remember, exothermic reaction for formation, exothermic is always more stable than endothermic. So endothermic means that this reaction is not stable, hence nitrogen is not readily to oxidize. So A is incorrect. So as for atomization of nitrogen, it is more endo than oxygen. Hence, we say that NO has a stronger covalent bond. Therefore, B is also wrong. And then this one, we say that half N2 plus half O2 give NO. It is also actually known as the bond energy. So for your information, how does the nitrogen looks like? So you can see that the structure of the nitrogen monoxide actually looks like this. This is a radical. Okay. So you have a triple bond in here, actually. Triple bond O. Okay, you have oxygen. Okay, you have a lone pair electron at the oxygen in here. So this is how the nitrogen monoxide actually looks like in terms of Lewis structure. Since NO has triple bond, so that is why it is more stronger. You require more energy to break them. So bond energy is basically breaking the covalent bond in here. Okay, so when you break the covalent bond in here, you form nitrogen and also oxygen, isn't it? Okay. So that is why at the same time we say that this is atomization. It can also be the bond energy also at the same time. So the best answer in here is C. Okay. Okay. So Ken, any questions so far? Okay, so no problem. That is for number 2. Okay. Okay, so immediately we go to number 3, shall we? Okay, so let's go to number 3. Okay, number 3 is a bond-Haber cycle of a white solid is formed. So the boiling cycle is shown below. So you have barium, half oxygen, give BaO. So you must know by yourself that This is the formation. This is the enthalpy change of the formation. Okay. This is the formation, and then this is the atomization. Okay, and then this is the ionization energy. This is the ionization energy. I'm so sorry because my mouse, the battery depleted already, so I didn't have extra battery to replace my mouse, so I have to draw using this one. I actually have this board, but too bad I don't know how to use in this presentation mode, so that's why I'm not able to draw effectively lah. Okay, if you zoom or whatsoever, maybe yes I can, but in this second screen I'm not good at it. Okay, okay. So sorry, before that I have this one. Okay, so the ceiling, wait for a while, we go to that question only, then we answer to your questions. Okay, okay. So and then from the thermochemical data, what is the value of X? So in here, you should use the enthalpy change of formation is equals to the summation of everything. So you must know the formation is enthalpy change of the formation, okay, over everything is equals to the summation of everything. Sorry, because my I don't have a mouse to write, so lattice energy plus everything in there. Okay. Okay. So this is how we are going to this one. Okay, so that is for the this one. So if you press your calculator, what is your value of X? So your value of X is positive 751. Okay, so that means your answer will be C in here. Okay. Okay, so that is how you are going to answer for question number 3 in here. All right, so any questions that you want to ask for this? Okay, so I hope that is clear enough because it's quite straightforward, these questions. Just that it will take some time for you to calculate, so you must be very good in your calculations. Okay, okay, so let's continue. Number 4, the following is a half cell and their standard reduction potential. So the following reactant undergo redox reaction spontaneously under standard condition except. So you have to know what is the pair that you need to be used in order to deduce the spontaneity. Now, whenever you check inside the equation here, you must know that one of your species is at the left, another species is at the right. Okay, you have to know that one of the species is at the left. So for example, in B, you have H2O2 and also Mn2 plus, let's say inside your C. Okay, so when you know that your H2O2 and Mn2 plus, so your Mn2, one species must be at the right hand side of the equation, and then another species must be at the left hand side. So for example, in C, you use equation 3 and equation 4 to compare, and you reverse the equation 3 to find out the spontaneity. Okay, so let's have a look one by one how you are going to solve. So for A, there are no suitable equations in here because if you notice carefully, both MnO4 and also Cl2 are at the right hand side, left hand side, sorry. You see that? MnO4 and Cl2 are both at the left hand side, so there is no redox reactions in here. So when there is no redox reactions, so that is why we do not have a suitable equation for A. Okay, as for B, you use equation 3 and reverse equation 1. Okay, so you use equation 3 and reverse equation 1. So I'm going to highlight with different color so that you can see very clearly. So for B, I'm going to use blue color. So it is the MnO4 minus and also H2O2. So if in here you know that MnO4 is doing reduction, so your H2O2 must be doing oxidation. So the oxidation of H2O2 is the equation in here. Okay, so that is why you choose the equation 1 and reverse equation 2. So it's positive 1.52 plus negative 0.68. You get positive 0.84, therefore reaction is spontaneous. Okay, as for C, as I already highlighted, you use MN equation 4 and reverse equation 3. So you get positive 1.77 and minus a plus negative 1.52. You still get a positive 0.25. So that is why the reaction is spontaneous. And finally, for equation number 4 in here, so you should have equation number, wait, I couldn't see that. This one. Okay, so you have the Cl minus, which is the reverse of the equation 2, okay, with H2O2. So H2O2 must use this one, okay. So you have the equation, reverse equation 2 and also equation 4. So reverse equation 2 and equation 4, you have a negative 1.36 plus positive 1.77. You get a positive 0.41. So that is why the reaction is spontaneous. So since the reaction is spontaneous, then the reaction is possible. So the best answer in here for number 4 is A. Okay. Can you understand? So you must be very good in choosing your pair of the reactants, right? Okay, so that is for number 4. Okay, are you ready for number 5? Okay, so let's go to number 5. Okay, an electrochemical cell is made by connecting a standard hydrogen electrode to a half cell consisting of a magnesium electrode and saturated solution of MgOH2. So when the switch is on, voltmeter reading show 2.497 volt. Which of the following statement is not true? Okay, so in here, electron flow for magnesium to the platinum, which is actually correct because magnesium is the anode and the standard hydrogen electrode is the cathode. Okay, and then number 2, the solubility product of the MgOH2 is 5.06 times 10 power negative 12. So this one, you don't zero back your calculator. If you zero back your calculator, then you will not get this answer. Okay, so first you calculate your E cell equals to E naught cell plus 0.059 over 2 log. It's actually minus, not plus. Sorry for that. It's actually minus. I think I made a mistake in here. It's minus, not plus, minus, not plus. Sorry for that. Okay, minus 0.059 over 2 times x times 1.0 over 1 square, which is the standard hydrogen electrode. Therefore, your concentration of Mg2 plus, which is your x, equals to 1.08 times 10 power negative 4. Then you, as the solubility product, MgOH2 solid give Mg2 plus 2OH minus. Therefore, X give X and 2X. So therefore, your concentration or your KSP of the MgOH2 is 1.08 times 10 power negative 4 times 2.16 times 10 power negative 4 square. So your KSP is 5.06 times 10 power negative 12. So this one, if you straight away press your calculator now, 1.08 times 10 power negative 4 times 2.16 times 10 power negative 4 square, you get around 5.0403 if I'm not mistaken, which is not accurate. So this one, if you want to calculate accurately, don't zero back your calculator, because if you zero back your calculator, then you will never get this answer. Okay, so in here, number B is also correct. Okay, C, a few drops of sodium hydroxide is added to the solution. So what happened when sodium hydroxide is added? So when you added sodium hydroxide to the MgOH2, so the equilibrium will shift to the right. So if the equilibrium shift to the right, this will make the concentration of the OH minus increase, hence cause the equilibrium shift to the right. So equilibrium shift to the right, so the voltmeter reading is going to increase. So that is why C is also true. And then D, concentration of the OH-Mg in here, as you can see in here, concentration of OH minus is 2.16 times 10 power negative 4. So D is wrong. Okay. So the best answer in here is donkey D. Okay. Okay, can I understand? Okay, so that is for how you are going to answer for number 5. Okay, it's a little challenging because you require some calculation and then some understanding also at the same time. So I wouldn't advise students to focus on this question too much. Skip to other question first. Okay. Okay, so if no problem, then we go, teacher, how to get the concentration of the, Mg and OH? That I already calculated for you. You use the Nernst equation in here. Do you see that? Okay, I already used this equation to show you already. Okay, so you see, you use the Nernst equation. Use the Nernst equation to calculate. Okay, so you substitute accordingly to this equation. Minus 0.059 over 2 log x times 1.0 divided by 1.0 square. So you are able to get this. Okay, slowly calculate Your E cell is 2.47. Your E cell is 2.47. Your E naught cell is 2.38 in here. I'm so sorry I didn't substitute accordingly. This one is 2.479, 497. Okay, and then this one is 2.38. Sorry, I I may be a little bit handicapped in the drawing in here because my mouse don't have battery already. I didn't change my battery for the mouse. Okay? I know that this is 8. Sorry for that. Okay. In this case, it's 2. In this case, the Nernst equation in here is 2. Okay, Nernst equation is 2. Okay, try to usually in structure essay, 3 marks goes to substitute equation substitution answer. 3 marks in here. Usually it's like that. So I would really encourage you all to write the Nernst equations. Okay. Okay, so that is for number 5. Okay, so let's move on to number 6. Let's not focus too much on the questions. Number 6, 2 electrolytes are connected in the series shown in the diagram. So if the mass of the increase in cathode in A is 15.6, what is the mass of the gaseous product formed at the anode in the electrolytic cell? Okay. Okay, so one is for silver one is for silver. But if you compare to standard hydrogen electrode, usually it's 2 electrons. It won't be 1. Trust me. Okay. Okay, so how to calculate this one? First, you need to calculate the mole of copper. So 15.6 divided by 63.5, you get 2.47, 2457. So since copper 2 plus 3 minus give copper, so mole of electron is equals to 0.4914 mole. And then you use your anode 2H2O give 4H plus O2 plus 4E minus. Now, I'm so sorry, this one sometimes the objective does not give you, by hook or by crook, you have to at least memorize the half equation at anode and cathode, especially for the electrolysis of water. Try your best to remember, okay or not. Okay, because sometimes objective question can be like this, they don't give you all the equation. They expected you to know by yourself. So if you don't know, then you won't be able to solve this question. Okay, yeah, there are a few years also like that. You can look back at the past year question and you see So for anode, the half equation you use is the 2H2O plus give 4H plus O2 plus 4E minus. Whereas at cathode, so the cathode in here, the half equation is the 2H2O. I'm going to speak slow a little bit in here. Because I don't know how to use the board on the writing screen. Plus 2E minus. This is the problem with the using the board in here, because they cannot write on the second screen very well. Okay. So I have to use my mouse pad and write slowly Okay, sorry for that for all the inconvenience caused. Okay, if anyone know about how to use this stuff, can you teach me? So that in our next semester, I'll be able to show you better. Because Mr. Chu is very clumsy in tech. Old man is like that. Okay, so that is the half equation. Okay. So some of you demanded, teacher, if when NaOH is added, OH react with hydrogen ion and the hydrogen ion concentration. In this case, it usually goes to, I scroll back to the question. Okay, in this number C1, usually this question is referring to MgOH2 lah, definitely not H plus. It's definitely going for MgOH2. Of course, it's my fault also lah, because I didn't specifically say that if NaOH is added to the magnesium half cell my fault in here lah. Okay, yes, you are correct, Jayu. Okay, it will not react with the H. Yes, you are correct. Okay. Teacher, how to get the value of 0.4914? You mean for number 6, is it? This one? Stoichiometrically 2 to 1 times 2 lor, times 2. Okay, times 2. Okay, times 2 times 2. Okay. Okay, so with that, your mass of the oxygen is 0.1229 times 2 times 16. You get 1.97, which is your answer in here. Okay. So with that, that is how you're going to answer for question number 6. I hope that is clear enough, the explanation. Okay, so for the cathode, this is the half equation. Try your best to remember. Okay, this is a half equation at cathode. Sometimes you have to memorize. This is the half equation for anode. So you have to try your best to remember some. Okay. Teacher, can I ask about how anode is to determine which equation you use in here? Now, for the selectivity of the electrolysis in here, I will recommend you to go to my YouTube. You search inside my YouTube channel. I teaches you all how to select the selectivity inside aqueous solutions. I explained that in details. So you might want to go to my YouTube and learn more. I'm so sorry inside here, because of the time constraint, I'm not able to express everything. So sorry for that. Okay, you can go to there. Okay, number 7. Diaphragm cell is used to electrolyze brine to obtain chlorine gas and useful side product, which is true about the diaphragm cell. Okay, so this is the typical diaphragm cell, as you can see in here. Okay, so in the anode compartment, you have the liquid must be in the anode must be higher than the cathode to prevent back pressure, because if you have back pressure, then the NaCl will be diluted. So when NaCl is diluted, then your selectivity will be influenced. Okay, so that is why it must be higher And then number 2, in an anode you use titanium, whereas cathode you use steel. Okay, so that is why your stainless steel is used as anode is wrong. Anode you use titanium. Okay, and then C, the useful side product. So the product of electrolysis are Cl2 at the anode, while H2 and NaOH is produced at the cathode. About how the H2 and NaOH is produced at the cathode, you can always refer to my diagram in here. Okay, and then finally for D, asbestos is used to the diaphragm to allow the cation to pass through. So in here, the best answer is don't D. Okay. So that is how we are going to solve for question number 7. Okay, Ken? Any questions that you want? So application part sometimes can be also quite important. Try your best to remember. Okay, so can graphite use as electrode or not? In this case, no. In this case, specifically is for, you must memorize. Anode is for titanium. Cathode is for steel. Okay. Okay, number 8. The following graph is obtained when a physical properties is plotted against proton number of the period 3 element. What is this property? So this property is showing what class? This property is showing first ionization energy. Okay, in the meanwhile, how should the electrical conductivity graph looks like for period 3? How should the electrical conductivity graph looks like for period 3? It shows increase, then decrease like that. So this is electrical conductivity. Okay, what about melting point? So this is the melting point. You look at the red line, not the blue line. The blue line is for period 2. Okay, blue line is for period 2. Red line is for period 3. Okay, and then last but not least, atomic going across radius period. So atomic radius decrease. Okay, so these are the graph of how they are supposed to look like for the physical trend of the period 3 for these few things. So try your best to remember. Can? Okay, so that is how you are going to explain for number 8. Can? Okay, so let's go to number 9. The temperature of decomposition temperature of magnesium and calcium are 400, 540, and 900 respectively. Which statement best explain the differences of the temperature, difference in temperature? Section C later, I will explain in section C. Cindy, please be patient. I will go to section C and we discuss together. Okay, A, magnesium carbonate has a stronger lattice energy than calcium carbonate. Is it true? So these are actually all the points in here. So magnesium lattice energy of magnesium carbonate, yes, it is indeed stronger than calcium carbonate. It is true. This statement is true. However, it is irrelevant to why is the decomposition temperature of the magnesium carbonate is lower than that of the calcium carbonate. Okay, so irrelevant. Okay, and then number B, Mg ion has a higher polarizing power, which is correct because you have a smaller charge. High charge, small ionic radius means that you have high charge density. High charge density will lead to high polarizing power, so therefore B is correct. C, Mg atom has a smaller atomic radius. Statement is correct, but we are not using atomic radius to compare. We are using ionic radius, so C is irrelevant to explain in this. And then D, Mg2 plus has a smaller charge density, which is wrong. Mg2 plus has a higher charge density. So therefore, the best answer in here is boy B. Okay, very straightforward. Okay, so if you were to explain about the thermal decomposition temperature, these are the basic 5 points that you have to use to explain about how are you going to explain about the thermal stability in here. Okay. Okay, so with that, that is for number 9. So teacher, for number 6, or is it D? I think I made a mistake in here. So it's D. Number 6 is D. Sorry for that. It's 3.93. 1.229 times 32. Yeah. 3.93. Yes. Sorry. Answer is D, donkey D. Yes. Sorry for that. I highlighted wrongly. The answer is donkey D. Okay. But I show you the calculation already. So you should be understand. Okay. Thank you very much for that. Fatsam. Thank you very much. Okay, so between CO3 2 minus NO3, which is the most stable and which is the least stable, it depends on the cation. See on how you are comparing with. If you are comparing using magnesium, okay, if magnesium, the thermal decomposition temperature of the magnesium hydroxide is the highest, okay, whereas this one you can use ChatGPT to check if you want to know, okay. You can use the ChatGPT to check the temperature. So in this case, it seems that magnesium hydroxide should be the highest. Or magnesium carbonate. Magnesium carbonate should be the highest, followed by magnesium hydroxide, then magnesium nitrate. There is a way of how you are going to handle this. So in STPM, there's only 1 year that asks the anion. Actually, anion is not really inside our syllabus. Okay, so don't bother too much about it. Right? Okay. Then number 10, beryllium and aluminium show diagonal relationship in the periodic table. So which of the following statement is true in regard to the diagonal relationship? 1, beryllium oxide and aluminium oxide are covalent. No, they are both ionic compound. Yes, I know there is sometimes they compare anion, but only one or two times only out of the 22 past year question. So I'm not sure why are they doing that, because it is not part of the syllabus. Okay, so yeah, I'm not sure why. Okay, you just focus on more important part lah. This small part, try to ignore it. Can? Okay. If it's really come out in STPM, then no choice lah, because it is outside syllabus to compare the anion. It is outside the syllabus. In the syllabus, you are to compare group 2 cation, but not the in between the anion. No. Okay, then back to the question. 2. Beryllium chloride and aluminium chloride form dimer in gaseous phase, which is correct. So they exist as B2Cl4 and L2Cl6 even in the gaseous phase. 3. Beryllium chloride hydroxide and aluminium hydroxide are amphoteric, which are correct. So the equation, do I write? No, I didn't write. Okay. And then number D, salt of the BH2O4 2 plus and LH2O6 3 plus undergo hydrolysis to form acidic solution, not basic solution. So in here, 2 is correct, 3 is correct. So the answer in here is point B. Okay. Okay. So that is for number 10. Okay. I'm so sorry to say this to you, XYZ, that sometimes they compare the anion. Yes, they do compare the anions. Yes, they do compare. I never said that they didn't. But like I said, it is out of the syllabus context. So I'm so sorry for not able to discuss in here. Okay. So there's only 2019 or 20 that year, one time only that asked in structure. And then 2017 asked a 1-mark question on that. Okay. So don't be bothered too much by it. It does ask, but not very frequently. Okay. Okay, number 11. Which of the following is true regarding to the inert pair effect by lead? So inert pair effect is a result of large energy gap between the 6s and 6p that causes the 2 electron in the 6s to be non-reactive, hence inert. So as a result, it causes the +2 to be more stable in +4. Okay, so in here, A, the first 4 ionization of energy of lead are lower than tin. Actually, first ionization energy of lead is slightly higher than tin. Why? Due to the ineffective screening of the 4f orbital. And then number B, inert pair effect is caused by the ineffective screening, so which is of 5f and 5p, which is wrong. The ineffective screening is more to 4f orbital. Okay. And then C, the +2 oxidation state is less stable than the +4 oxidation state for lead, which is incorrect, because +2 is more stable, not less stable. And the answer D is correct. Lead 4 oxide and decompose to lead 3 oxide when heated strongly. Okay, it will form. Okay, it will form to lead 2 oxide PDO when you heat it strongly. Okay, so with that is how we are going to answer question number 11. Teacher, is inert pair effect only show for PB or all group? Specifically for PB? Yes, specifically for PB. Okay, number 12. Borosilicate glass is one of the most common glass used to the of typical following statement is true regarding the borosilicate glass. So its main component is SiO2 and BO, which is wrong. It's actually B2O3 and silicon dioxide. Okay, and which is used in the laboratory as reagent bottle with low coefficient thermal expansion. So that means if you want to heat the chemical inside, let's say glassware, okay, so you require this borosilicate glass as the glassware to prevent the cracking, because borosilicate glass has a relatively low coefficient of the thermal expansion. Okay. Okay, so in here, then the answer in here is donkey is resistant to thermal shock. That means it can absorb heat very well. So that is why it is suitable to be used in a lot of the laboratory apparatus. Okay. Okay, so any questions that you want to ask for question number 12? Okay, so hopefully no problem. So if no problem, let's go to question number 13, shall we? Okay, chlorine react differently with aqueous sodium hydroxide under different conditions. Which of the following is true when chlorine is bubble through hot concentrated sodium hydroxide? So when chlorine is proportionate in hot NaOH according to the equation, 3Cl2 plus 6NaOH give 5 NaClO plus 5 NaClO3 plus 3H2O. So the changes of oxidation state is from 0 to -1 and +5. Okay, so A, chlorine undergoes reduction, which is wrong because chlorine undergoes disproportionation. One of the product can decompose in the sunlight to form oxygen gas. There is no such product inside the mixture here. And then C, the oxidation state of chlorine after reaction is +-1 and +5, which is actually correct. Okay, and then one of the one of the product is mainly used as a bleaching agent, so it is also inappropriate lah. Okay. Okay, so with that is for question number donkey D. Sorry, 30C. 13 is C. Okay, so with that is how you are going to this one. Thank you, Mr. Go, for helping me to explain. Okay, then number 14. A few drops of potassium thiocyanate is added to a test tube containing an aqueous solution of iron 3 sulfate. Which of the following statement is true regarding to the reaction? So in here, you have to remember that the equation goes like this. FeH2O 6 3 plus SCN minus give FeH2O 5 2 plus SCN 2 plus H2O last is a displacement reaction. So in here, the color changes from yellow to blood red. Nowadays, they start to accept that Fe3 plus is brown, but still the general statement of the iron is still yellow lah. The general statement of iron 3 plus is still yellow lah, according to the STPM, because we have 2 years stating that already. So, but in the real situation, if we look at Fe2 plus, it's actually brown. So, but still they insisted they want to say yellow lah. Okay, so nevertheless, never mind. So the black rod solution is caused by the FeOH2. So in here, oxidation number still remain 3. Both of them are still +3 oxidation state, whereas both of these complexes has the coordination number is equals to 6 because they have 6 dative bond. So the best answer in here is C lah. Okay. Okay, so with that is how you are going to solve question number 14. Okay. Okay, so any questions in here? Okay, so try your best to remember this equation because this equation is extremely common in the STPM this equation for the blood red, this one. Okay. Okay, so if no problem, we go to the last question, 15. Many transition metals are used as catalysts for various chemical reactions. Which of the following is the reason for use to use platinum as the catalyst for the hydrogenation of alkene? So platinum has empty d orbital for reactant to form temporary bond via chemisorption. Due to platinum, they have active site and weaken the HH bond, causing the C2H4 to form C2H5 first before forming C2H6. Okay. Okay, so the best answer in here is A lah, because they have d orbital to form a temporary chemical bond. Okay. Okay, so with that is all for the 15 objective. Okay, let's have a look at some of the question. Teacher, can I ask, will splitting of d orbital still occur for 3d0 and 3d10? Actually, yes. Splitting of the d orbital is a result of the valence electron in the 3d is repelled by the ligand. So it is the electron repulsion that caused the d orbital to split. Okay, it's just that when because d orbital is empty or d orbital is complete field, there are no electronic transition occur. Okay. Okay. So that is why it is still splitting. Okay, it is still splitting. Okay, and then is it acceptable to use displacement? We use substitution. We use substitution. Or ligand exchange also can. Ligand exchange also can. Okay. Okay, how are we going to determine the coordination number? The coordination number depends on the complexes. If there is a 6 native bond, then coordination number is 6. Okay, I've already explained this in one of my YouTube, so you can go to the YouTube and have a look. Okay, okay, so thank you, Mr. Go, for helping us here. Okay, okay, thank you very much. Okay, anything else that you want to ask for this objective question before we move into the structure? Okay, so hopefully no problem for the objective because they are quite straightforward and hopefully you all can understand. I've already explained them in quite details. So yeah, okay. Okay, so let's go to the structure. So in the structure, my advice to student is you are asked advice to spend 15 to 20 minutes to answering. So the answer should be short and clear, and then do not over focus on one question. Nowadays, STPM is your section B also have to write on the test pad. Okay, your section B also have to write on the test pad. So you have to make sure that you transfer all your answer into a test pad, and don't forget to bind together. When I go for invigilation, sometimes I see students forget to bind the answer sheet together. No. So please be careful. Double check before you submit your paper. Okay, this one, some of the students they make careless mistakes. So please be extra careful. All right. Okay, so my advice in here is to spend 15 to 20 minutes for these questions. Okay. Okay, let's have a look at the structure question. Number 16, disulfur difluoride S2F2 is a liquid often used as an insecticide to fumigant in the wooden structure to control termites. A. Write the thermochemical equation for the enthalpy change of formation and atomization for disulfur difluoride. So the standard enthalpy change of formation is 2S solid plus F2 give SF2 liquid. The question already said, so state of matter is a must. Teacher, can I use S8 or not? Now you can also use S8. So if you use S8, your answer will be 1 over 4 S8. Okay, so both of them are accepted as per STPM 2016. I don't know if there is the latest this one for it, but so far both S and S8 are accepted in STPM. Okay, and the standard enthalpy change of the atomization is S2F2 liquid give 2S gas plus 2F gas. So it will atomize to become gaseous atom is for a compound. Okay. So that is why please be able to distinguish in between atomization for element and atomization for compound. Atomization of element is a standard one. What do I mean by standard? If you chlorine, you have to write half Cl2 gives Cl. So that is the standard atomizations for element. But for compound, when you want to atomize compound, you atomize the whole molecule to become the gaseous atom separately like this. Okay. Okay, B, by using Hess law, calculate the standard enthalpy change of the formation of disulfur difluoride if the enthalpy change of atomization of sulfur fluorine and disulfur difluoride are positive 128, positive 109, and positive 678 kilojoule per mole respectively. So you must be very good in writing thermochemical equation because the question already said using Hess law. So you have to state using Hess law. Okay, so these are the respective thermochemical equation that you can have. So then what do you want to find? You want to find the formation of the SF2. So you reverse the first equation times 2, second equation also times 2, third equation you reverse. Okay. So at the end, you get 2S solid plus F2 gas give S2F2 liquid. So enthalpy change of the reaction is negative 204 kilojoule per mole. Okay. So pretty straightforward in here. Okay, any questions? If you give me 1 minute, excuse myself for a while. I have to get my drinks over. Sorry, I go and get my drinks. Okay. Okay, let's answer some of the question. So, teacher, atomization question, write short form or full? Atom enough already. Like how I show to you on the screen is enough already. Actually, to be honest, we don't really very strict on that. Okay. So if I can I ask in energy cycle, energy level diagram, we need to put the value of positive or not? Usually we we put lah. Usually we put lah. Okay. Okay. I think I answered already. Atom is enough already lah. Atom is enough already. Okay. Okay. So okay. So the answer for this is negative 240. Okay. Write the positive. Write the positive 12. Okay, just write the value enough already because the value itself will represent the enthalpy change. The value itself will represent the enthalpy change. Okay. Okay, so now okay. So we goes for C. Based on the information of B, construct an energy level diagram. Now I'm so sorry lah. Maybe different teacher they have different way of teaching. So in here I use my own way of the energy level diagram. So if you can accept, then you just accept lah. If you cannot accept, then maybe you have your own methods to try that. Maybe other school teachers they teaches you. I'm not sure about that. But the energy level diagram that I use in my discussion is always one kind only, which is I use this one. So all the informations that you need to relate in here is atomization of the sulfur, 2s solid give 2s gas. You also need to relate F2 give 2F gas, so positive 218. So you also have to relate the atomization, S2F2 liquid give 2S gas and 2F gas. And then 2s solid plus F2 give S2F2 liquid. So the formation is negative 204. So in here, teacher, how do you know which you construct the energy level? So in this case, you relate 256, 218, and 204. You sum up these three, okay, this 1, 2, 3. So the total in here, we don't look at the positive negative. Don't look at the positive negative. So the total of this equation 1, equation 2, and equation 4 in here will still equals to, like I said, don't just look at the value. Don't look at the positive negative. You get 6, 7, 8 in here. Okay, you also get 6, 7, 8. So in other words, the S2, F2 is at one side, and then the rest is on the another side. Okay. So in here, this is how we are going to construct. That is why Born-Haber cycles mention the following things. Enthalpy change. What does Born-Haber cycle mention? Born-Haber cycle mention that enthalpy change of the reaction is the same no matter the reaction take one step, okay, or series of steps. So that is what series of steps in here means in the Hess law in here. Okay, so the enthalpy change should be the same. So that is why I uses this diagram to teach you. And then in the y-axis in here, we use enthalpy. You write enthalpy in kilojoule, and then just write the value is enough already. Always remember, if it is endo, reactant low, product high. Okay, endothermic process reactant low, product high. Okay, so the arrow goes up in here. So this is the energy level diagram that I usually use to teach my student. Maybe, like I said, different teacher, they have different methods. So I will, it's not up to me to say whether it's accepted or not, but this is the one that I use for my own school. Okay. Okay, so with that is all for the question for number 16. 0 for the element. Okay. Okay, so actually it's not 0 I don't know, But from the angle, should we label 0 at the axis is actually no need lah. No need to 0, because enthalpy, if 0 means that you don't have differences. Okay, so usually we don't encourage put 0 lah. No need. Okay. Okay, teacher, how do we know we need to multiply the value? It has more than 1 mole. Sometimes the question already multiply the enthalpy change, but sometimes they don't. This one, I'm so sorry, Shikin, that okay, in STPM, usually they will give in the what? Usually they will give in the this question, you know. Usually they just give you a statement like this. The equation you have to come up by yourself. The equation you have to come up by yourself. And when it is given to you like this, you should be following the standard way. So, for example, atomization. So for atomization is S solid give S gas, half F2 give F gas. So this is all standard equations. These are all standard equations in here. So you multiply by 2. Like in this case, you multiply this one by 2, isn't it? You multiply this one by 2. Then this one you also multiply by 2. It is in order for you to get, and then this one you reverse it. Okay, you reverse this one. So it is in order for you do all these changes. It is in order for you to get to your answer, you know. So that is why Hess law allows you to do all that in order to get to your final answer, what you really desire. So your desired equation is 2s solid. Okay, 2s solid give F2. Okay, give S2 F2 liquid in here. Okay, so you have to this one. So teacher, this is Born-Haber cycle. No. Born-Haber cycle is another already. This is also a form of energy level diagram. This is a form of energy level diagram. Actually, Born-Haber cycle is also an energy level diagram. Okay, Born-Haber cycle is also an energy level diagram. Okay. Okay, so anything else? But like I said I don't know any other teachers. You have to follow the way that your teacher teaches you. But if you were to follow my lesson so far, I only teach one type of the energy level diagram, which is this one. So yeah. I'm so sorry. So maybe different teacher, they have different way. So nevertheless, I have no right to say that my answer is the only way. No, you just follow to whatever your teacher teaches you lah. Okay, so this is the way. How to differentiate it? In Born-Haber cycle is usually used to relate lattice energy, hydration, formation, ionization energy, electron affinity, and also formation. Okay, but like I said, actually, Born-Haber cycle is also a part of energy level diagram also. Okay. Okay, so with that is for question number 16. Okay, any else question? Okay, so hopefully it's clear enough. Mr. Chu, is there a mistake in the head cycle? So far, I don't think so lah. No mistake. Okay. So far, there is no mistake. If there is any mistake, please let me know. I may be wrong. Okay, I may be wrong. 256 is yeah. I think I put wrongly somewhere also already. Mana salah Can you help me to identify it? 6, 7. I think I terbalik this one already lah. Yeah. You're correct. You're correct, my dear. Thank you very much for helping me. I think I terbalik put these two already. This one should be another way around. This one should be 2s. This one should be 2s. Sorry, reactant high, product low. You're right, my dear. Thank you so much for helping me. I give you the wrong diagram already. Thank you very much. You are correct, my dear. Mr. Chu also sometimes very clumsy. Okay, you are correct. You are correct. Can you help me to correct this one, please, ladies and gentlemen? And then this is 2S. Terbalik lah, sorry for that. Okay. Okay, so this is the correct one. Sorry, I put in terbalik. Okay. Yes. Thank you very much for helping. Okay. Okay, because 204 is from 2S. 204 is from 2S solid, give S2F2, so reactant high, product low. Okay, and then this one is the atomization. Okay, the equation 3 in here. Equation 3 in here is the I use different ink so that you can distinguish it. Okay, equation 3 in here is F2, S2, F2, give 2S and also 2F. So it's a S2, F2, endothermic. So endothermic is reactant low, product high. Okay, correct. Thank you very much, child. Okay, thank you very much for helping me. Mr. Chu also human also, so sometimes make mistake. Okay. Okay, so that is how you are going to sketch the cycle. Teacher, can I write as the 1/4 S8 instead of 2S? Yes, you can. Yes, you can. I think I already explained in the previous slide in here. You can also write 1/4 S8. Yes, you can. Okay. 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 What else? Okay. So thank you very much. And shall we move on to question number 17? Okay. So sir, energy level diagram can be drawn in another pattern, right? If the equations are correct. Hey. Can. I to be honest, I don't know. I cannot say for sure. But what I can say for sure is when I don't know I don't know different teacher, they have different approaches. But for me, this is the safest energy level diagram, because in energy level diagram, if it is this diagram clearly shows you about how does the process actually take place in here. If this process is exo means that reactant high, product low. Okay, so and then if endo is reactant low, product high. Okay, so I don't know. I'm so sorry if there is any other methods already, but so far this is what I used to teach my students. So if there is any mistake that I did, so you just follow your teacher's teaching. Okay, but this is my way. Okay. Okay. If Hess-law can use one Haber cycle, can. Yes, you can. Okay. Okay, so with that is how you are going to answer for number 16. There are many questions here. Okay, very good. Okay. Okay, number 17. Kaolinite Al2Si2O5OH4 is a hydrated aluminosilicate mineral which is able to absorb cation in aqueous solution on the surface according to the following equation. So M plus aqueous plus Al2S2O5OH3OH give this is reversible. Give Al2Si2O5OH3OM. So you can see from the equation in here, this is somehow the replacement of the hydrogen ion by the metal. So it is the kaolinite that is able to absorb the cations. this is how the kaolinite to absorb the cations in here, okay? So A, state the oxidation number of the silicon in the kaolinite. So it is 2Al plus 2Si plus 4O plus 5O plus 4OH equals to 0. So aluminium is plus 3. Si is what you want to find. So 5 times negative 2 plus 4 times negative 1 equals to 0. So Si is plus 4. So we actually only one oxidation state is plus 4. So if you show this answer, then it's good enough already. Just write plus 4, then enough already. Okay. Okay, B, state why basic clay is not suitable for most plant. Why is it basic clay not suitable? Because in alkaline condition, concentration of the cation will be low. Why do we say if concentration of the cation is low? Because the OH minus will react with the H plus, okay, well, if you use alkaline, H plus will react with the OH minus. So as a result, concentration of the H plus will decrease. If concentration of the H plus decrease, equilibrium shift to the right. So that is why we say that concentration of the cation is low because equilibrium shift to the right. Okay, since the H plus decrease already. Okay. So actually, this is the modification from STPM 2003, which is 21 years ago questions. Yeah, I just take from there. I don't know because there are not many questions that ask in regards to the zeolite. So I can only make use of all these very old questions to ask you all. And then if you have seen my school's trial examinations, we also have fuel cell. Fuel cell has never been asked in STPM so far. So I would also hope that you take notes on the fuel cell a little bit, especially for the chapter 2. Okay. So there are a lot of things that haven't asked in STPM, especially when it comes to the near end of the STPM system, syllabus system. So you have to write, okay? So okay, we finished C first, okay or not, Zoe? We finished C first, then I'll go to your questions, okay? Okay, suggest a use of kaolinite with reference of the above equation. Either you say cation converter resin or ion converter resin. Okay, so this is, you can convert the cation. Teacher, can I say cation absorber? Yes, you can. You can also state cation absorber. Can. Ion exchange resin. Ion exchange resin is also cation exchange resin, cation convert resin also can, either one. Okay. Now, this is the one that you want to ask. So we go for the explanation first. By stating the repeating unit of in the silicate sheets, describe the common characteristic presence in here. So the repeating unit of silicate sheet is Si2O52 minus, and then each silicate share 3 of its oxygen atom with other silicates in here. And then state physical properties, either you say electrical neutral or slippery. Okay, so some of you ask, teacher, although here no need to draw, may I ask how to draw the structure of the silicate sheets? Okay, this is asked in STPM 2021, if I'm not mistaken, that requires the students to draw the this one, isn't it? So in here, you can draw like this, you know. My drawing may not be very beautiful, but this is how we are going to draw a repeating unit of the silicon. So you draw SiO. Okay, this is minus. Okay, so you draw SiO. Okay, this is OSi. Okay. This is also minus. This is O. Okay. So you see on how one structure of the silicate share with 3 other silicon atoms. So this is how you are going to draw the structure of the silicate sheets. You can draw like that. So from here you can see Si2O5 2 minus. Okay. Okay. Teacher, do we need to write the state of the equation? If possible, try to write state. Nowadays they stress the state very much already. Yeah. Is repeating unit the same as basic unit? Basic unit is SiO44 minus different. It's different. Basic unit is SiO44 minus. Okay, what else? Okay, so that is how you are going to draw the silicate sheets repeating unit, like how you wanted to know. So this is a recommended structure, okay. Okay, so with that is for question number 17. Do we have to draw the silicate structure? We need to label it. Label as in what? Because you're answering the question, so no need to label already. But you have to try your best to learn to draw that because it's negative. So you want to show how Si2O5 2 minus looks like. You want to show this formula or what? Okay, so try lah. Si2O5 2 minus, this is how you draw lah. Okay. Okay, can? Okay, so if no problem, then we go to the essay question, shall we? Okay, so last but not least, section C, 30 marks. So try your best to answer only 2 questions. So you are advised to spend 20 to 25 minutes in this session. Do your best to present in an essay full with content related to the questions. Point form table is allowed, but not advisable unless you're really confident. Nowadays, when they come to essay, they really wanted you to write like essay long. So I don't really recommend this one. Okay, teacher, can you show how to determine the repeating unit of the diagram given? This one, I think in my YouTube I explained that, isn't it? Can you look back at the YouTube? I think I showed that before. Teacher, if you write the correct equation but the wrong physical state, will it be right? It is wrong. If your physical state is wrong, then it's wrong. But nowadays, STPM is very good in the sense of a lot of equations that give you what state of matter already, unless it's a very basic one. Okay. Okay, so never mind. As we go through, then we go through each of the questions. Okay, let's go to the first essay question. Like in this case, electromotive forces for the following cell is positive 0.15. So you have PT, H2 gas, H plus aqueous, SN4 plus, SN2 plus. Okay, just now in the earlier on, I see one question. I go back to you because you are the one who asked this. This one. Okay. So, sir, may I ask, does the cell notation or cell diagram need to include the mole of decimeter cube? Actually, no need. Like this one is very standard. This one is very standard. So no need to include this one. Question usually they will give you, unless if it is a concentration cell. If it is a concentration cell, yes, you need to write the concentration. Yes. Concentration cell, then you need to write the concentration. Okay. But usually in the cell diagram, normal cell diagram, you do not require to really write the concentration. As long as the state of matter, everything is written, then should be okay already. Unless they really question sometimes uses concentration to ask, yes. But when you come to write the standard one, they usually do not require student to write the concentration. Okay. Okay, never mind. 1, draw a label diagram for the chemical cell, indicate the electron flow from the diagram. So this is the recommended. Okay, so you have to draw 2 half cell, each of them. So try your best to label everything. So this is 1.0 mole aqueous, H2, 1 atmosphere, 25 degrees Celsius. Okay, and then label salt bridge, platinum. If possible, this is you put anode. Okay, you label this is your anode, this is your cathode. Okay, full sentence. And then you also have to show the flow of electrons as in here. So try your best to show the flow of electron. Must label E minus to show that this electron flow. So yeah, this is how you should be drawing the diagram. Complete label complete label diagram here. Okay. Okay, so that is for the cell diagram in here. Okay, so let's go for the second one. Okay, so calculate the E naught for the SN4 plus SN2 plus aqueous solution. So you use E naught cell equals to E naught cathode minus E naught anode. So 0.15 is equal. Try yourself to label substitute. Even if the positive sign, try to write the positive. Positive 0.15 equals to E naught cathode minus 0. So you get E naught cathode equals to positive 0.15. Okay. Okay, so that is for number A1 and also A2. Okay. Okay, so can? Okay, so that is for A. Then shall we go for B already? Okay, number 3, if the acid in the cell above is replaced by sulfuric acid, electromotive forces of the cell become positive 0.158. Calculate the concentration of the sulfuric acid and pH of the solution if the hydrogen cell half cell. This is actually from 2021 past year. I also didn't notice that. But never mind, let's continue. So, okay. Okay, sorry, I go back to the previous question. Okay, Mr. Chu, is there any part of the drawing that must require us to draw with ruler and should be dashes by draw in the salt bridge indicating KCl solution inside? Wow, so detailed. I don't know. So far, we don't really go to that detail. I remember that in a very old syllabus, they insisted that the students should write saturated KCl. Yes, it was very, very old syllabus. Nowadays, you just label salt bridge is far more than enough already. Okay. As for the part of using ruler or not, ruler is for kekemasan, for tidiness. So I don't think they will really stress too much on must use ruler or not. But I may be wrong, but so far we don't really say that must use ruler to draw very nicely. No lah. If you draw ruler, draw nicely is for the presence of the examiner to mark your answer. So it's for the presence of the examiner to mark your paper. Okay, all right. So let's go back to the question. So try to write your overall equation. So your overall equation is the SN4 plus, if possible, write the state of matter. But in this case, the overall equation is not. But I really recommend you all to write the overall equation for this one. Sorry for the very slow handwriting. Okay, so this is the overall equation plus the hydrogen gas. Mr. Chu very bad in the tech. I do have the things with me, but when it comes to a live streamer, I don't know how to use the bot already. If it is in other platform, like I use Zoom, or Zoom very convenient. Okay, but when it comes to this one, Mr. Chu also become handicapped already. So just bear with Mr. Chu lah. Okay, sabar lah. Okay. Okay, AQ, okay, plus 2H plus lah. Okay. Okay, so this is the complete equation. So from the overall equation, you'll be able to come out with the Nernst equation, where the Nernst equation is E cell equals to E naught cell minus 0.059 over N log concentration of. Now, in this case, you also have to express for the partial pressure of the hydrogen. You must express like this, please. Okay, you must express like this. Okay. Okay, So then you substitute lah. Positive 0.158 equals to positive 0.15 minus 0.052 log 1.0 times concentration of H plus square times 1.0 times 1.0. So then you get your answer for the H plus is 0.732 mole per decimeter cube. Then your pH is negative log of 0.732, you get positive 0.135 for a three significant figure. Because the question used positive 0.158, which is also three significant figure. So your answer should also be in 3. And then your concentration of the H2SO4 is half of the concentration of the H plus, because one H2SO4 gives 2 H plus. Okay, so this is your concentration of the H2SO4 in here. Unit, don't forget to add. To add in your unit, right? Okay, so that is for question number 3. Okay, so with that, that is for 18A. Shall we go for 18B? Okay, so 18B sounds like this. In laboratory, chlorine can be prepared by reacting manganese 4 oxide and hydrochloric acid. With the reference of the standard electrode potential value below, predict the spontaneity of the reaction between manganese 4 oxide and hydrochloric acid under standard condition. So your under standard condition is 25 degrees Celsius, 1 atmosphere. So in here, we will give you a series of the half equations, so you must be able to choose by yourself which one is appropriate. So your reactant in now is manganese 4 oxide reacting with hydrochloric acid. So in here, you want to prepare chlorine gas, okay? You want to prepare chlorine gas. So it's actually between Cl minus to become Cl2. So HCl will produce Cl minus. So your manganese 4 oxide is MnO2, not MnO4 minus. MnO4 minus is manganese, manganate 7 ions. Manganate 7 ion. So manganese 4 oxide is MnO2. So you are choosing in between equation 2 and equation 3, and then you reverse this equation. Okay, you reverse this equation. Okay. Okay, so okay, so question. So teacher, is it advisable to give more dV? Yes. In the halfway of calculation, give more SF for accuracy purpose. Yes, I will definitely recommend that. Yes, it is only the final answer, then we round off to the suitable significant figure. Yes, you are right. Okay, you are right. Okay, so shall we go back to the question? So now you know that you should use this half equation. So MnO2 plus 4H plus 2E minus give Mn2 plus 2H2O. 2Cl minus give Cl2 plus 2E minus. So your overall equation, you must write the overall. MnO2 plus 4H plus 2Cl minus give Cl2 plus Mn2 plus 2H2O. So this is the overall equation. Then your inert cell is equals to positive 1.23 plus negative 1.36. You get negative 0.13 volt. So since inert cell is negative, reaction is non-spontaneous. So supposedly, under standard condition, your reaction is non-spontaneous. So so how to make this reaction happen? So that is why, if you still remember in your 4.5 last time, you use concentrated HCl. So if you increase the concentration of the Cl minus, this will somehow make equilibrium shift to the right and cause your chlorine to be produced in here. Okay. So usually in this case, when you want to deduce the spontaneity of a chemical reaction, there are 4 marks. One first mark goes for finding suitable half equation. Second mark, write overall equation. Third mark, calculate the inert cell. Fourth mark, if the inert cell is positive, reaction is spontaneous. If the reaction is negative, reaction is non-spontaneous. So that is the 4 mark usually you go. Okay. So one more. If I write more unsure equation, will the marks be? There is no deduction of marks. Don't worry, you won't be deducted marks. It's either 1 mark or 0 mark. You won't get negative marks. Don't worry about that. It's either 1 or 0. You won't get deducted. No, it's either 1 mark or no mark. Okay. Okay. So okay, with that, that is for question number 18. Okay, can we move on to the next one? Okay, then we go to the next one. Will teacher deduct mark? No, 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 no. If no mark, no mark lah, not deduct mark lah, no marks. Okay, the other marker. No mark and deduct mark is two different things. Okay, number 19. A scientist discovered a new element My with the proton 120 and the valence electron of 8s2. A. Compare and explain the melting point and the ionization energy of My with that of the barium. Okay. No, 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 don't worry, don't worry. You won't get wrong cancer right. You won't get that. No, 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 you won't get that. Okay. Don't think too much. Don't think STPM is killing everyone. No. It's either 0 mark or 1 mark. You won't be negative. No, there's no such thing as negative marks. Okay. Compare and explain the melting point and ionization energy of My with that of the barium. So melting point of My is lower than that of barium. Why? Because My has a larger metallic radius than the barium. Okay, so when going down to the group 2, the metallic radius increase. So when the metallic radius increase, the strength of the metallic bond is weaker. So that is why melting point is lower. Okay, so then for the ionization energy, so ionization energy for the My is lower than that of the barium because the effective nuclear charge of the My is lower than that of the barium. Okay. So these are the 5 marks. I see a lot when I question my student, they use the factors: nuclear charge, screening effect, atomic radius, then effective nuclear charge. I think that is a safer way. This is very good. Okay, so you should also include, because it is essay, so you try your best to write a lot. So you start from the nuclear charge increase when going down to the group. So as the more shell is used, screening effect increase, and at the same time atomic radius increase. Therefore, as a conclusion, as a result, effective nuclear charge decrease. That is why the ionization energy of My is lower than that of the Ba. So you explain in the full statement, should be no problem. Okay. Okay, so that is for A. B, using suitable equation, explain the reactivity of My with water and oxygen. Okay, so My is a very strong reducing agent. You have to explain, but so when it is a very strong reducing agent, okay, or you say that strong reducing agent, don't need to use the word very strong reducing agent is enough already. Keyword is strong reducing agent. Okay, so My react vigorously with cold water to form basic solution. Okay, you have to say react with cold water okay, because barium can also react with cold water. Then this one is even can. Okay. So you use My plus 2H2O give MyOH2 plus H2. This one you have to memorize, no choice. Okay. Okay, and then you also have to mention that My react vigorously or reactively with oxygen, or burn actively with oxygen also can, according to the equation. Now you form peroxide. Barium you already form peroxide. My also form peroxide, so it's MyO2. It's MyO2, not oxide but peroxide. Here, even barium is also peroxide already. Okay, so that is my recommendations for the answers for B in here. Okay. If aluminium react with oxygen, since aluminium actually can aluminium can react with oxygen by right can. Okay. Teacher, is metallic radius same as ionic radius? No. Metallic radius is atomic radius. Ionic radius is ionic radius. Okay, it's two different things. Okay. Ionic radius is more to explain ionic bond. So that is when we use ionic radius. Okay, metallic radius is actually atomic radius. If you say atomic radius is the same with metallic radius, same thing. Okay. In section C, first time write ionization energy. Can I write in the following sentence? I don't understand what you're trying to ask. First time writing ionization energy. Can I write the following sentence? Wakarimasen. Okay, so the magnesium react with nitrogen gas. Yes, magnesium can react with nitrogen gas. Teacher, how do we know My is reducing agent or oxidizing agent? Because going down to the group 2, you should ask in the first place, how do we know it's group 2? Group 2 is mentioned here, 8s2. 8s2. Okay. So it is the reducing agent, group 2. Okay. Oh, IE, can. Capital letter IE Don't write small letter. Okay, can. Okay. So that is for B. And then C, compare the thermal stability of MyNO32 with that of the MgNO32. If you there are 8 keywords that I always recommend students to write whenever you are answering this essay. First of all, is definitely saying that MyNO3 is thermally more stable than MgNO32. Second mark is writing the decomposition equation must be balanced. MgNO32 give MgO plus 4NO2 plus O2. If you want to write the state of matter also can. MgNO32 is solid, MgO is solid, NO2 and O2 are gas. Okay. If you want to write the state of matter, go ahead. Okay. Then you have to say Mg2 plus has a smaller ionic radius than My2 plus. Yes. Then this will cause the Mg2 plus have a higher charge density than My2 plus, hence high polarizing power. If it is not enough, you should also add the following statement. So the small ion, the high polarizing power of the Mg2 plus is able to distort the electron cloud of the large nitrate ion. And then seventh statement is by stating that hence weakening the NO bond in the nitrate. And then finally, furthermore, MgO is more stable than MgNO32. So you write this 8 statement, then you will get a lot of mark automatically. So they are fixed. That's why when you answer these group 2 questions, try your best to capture all the important points in here. Okay. Teacher, can we write partial state of matter or not? Can no problem. Either you write or you don't write. But chapter 1, chapter 2 must write. Chapter 1, chapter 2 must write. Inorganic chemistry, so far they don't really stress. If question give you, you write. If the question don't give you, then you don't write also, never mind. Okay. Okay, so with that, that is how you're going to answer number 19. But I don't recommend point form. Point form is just for teacher us to refer only. Okay. But I don't recommend point form. You should write in your essay because essay must write in essay paragraph Okay. Okay, anything else for this chapter 4? Okay, Ken? Yeah, so if no problem, then we move on to the next one. Okay, last but not least, number 20. Solid silver halide react with concentrated sulfuric acid to form HX gas, which is oxidized to X2 gas. The solid play important role in black-white photography. No need distort the whole electron cloud, not only O2. Distort the whole electron cloud, not only the O2 minus. Okay, using suitable equation, identify the solid halide. So explain your answer. So in here, your solid halide, the question already said that the solid halide play important role in black-white photography. Automatically, you should know that it is the silver halide is AgBr, okay, or silver bromide, okay. Okay, then you have to explain your answer So H2SO4 first act as a Bronson lauric acid. So you react X minus plus H2SO4 give HX plus H2SO4. If you want to substitute as Br, go ahead, can. Then H2SO4 acts as an oxidizing agent since it is a stronger oxidizing agent than Br2. So 2HX plus H2SO4 give X2 plus 2H2O plus SO2. You can also substitute as Br, no problem, because you already stated that X is Br. Okay. Okay, so that is how you are going to answer for 20A. So you can download the answer from my YouTube. You see YouTube there is a link to download the answer. Everything is in there already. Okay, so that is how you are going to answer A1. Okay, and then A2, state what happened when the silver halide is exposed to sunlight and write equations for the reaction that take place. So when UV is exposed to silver bromide, so bromide loses electron or donates electron to the conduction band. Now this is a very hard to get marks because the at that year the question insisted that you must mention the word electron is donated to conduction band, which is I'm not sure what is it lah. Okay, so you have to write the equation lah. Br minus give under UV form half Br2 or E minus, or you can also write as 2 Br minus Okay, so 2 Br minus okay, give UV. HV is UV lah. HV is UV lah. Give Br2 plus 2E minus. Okay, wait. Okay. Okay, there are so many questions here. Okay, okay. Teacher, if I write my2 plus as bigger ionic radius, can. Also can, yes, can. Can I exchange Br minus? Yes, you can, no problem, yes. You're answering to the questions already, ma. Yes, definitely you can write X minus as Br2. Yes, you can. Okay, then after that, silver 1 ion will be released will be then reduced by the electron release, or you write the half equation Ag plus E minus give Ag. So this will give your overall equation HBr plus Hb give Ag plus half Br2. Okay, so this was asked in STPM 2007, if I'm not mistaken. It was a very old past year questions also already lah. I purposely took out and asked because such question, application question, sometimes students don't read. They don't read because it's application. So what I try to tell you in here, don't underestimate all these small this one. Oh yeah, by the way, before I forget, for chemical test of the halide ions, for chemical test of the halide ion, we recommend use silver. We recommend use silver nitrate. Don't use concentrated sulfuric acid as a chemical test. They don't actually accept. That's what I heard. Okay. Because they said that, I imagine everybody in the lab do this experiment, mana tak mati, yeah, which is true lah. So usually they don't recommend sulfuric acid. Okay, so a simple covalent structure is true or a simple covalent molecule. The question is simple covalent. The molecule or not, it doesn't really matter anymore. Okay? But usually we set a simple covalent molecule. Okay. All right, so with that is for 20A. Okay, B. Chlorine dissolves sparingly in water to form the solution form can be used as a bleach. Using suitable equation, describe the reaction between chlorine and water. Identify the active ingredient for the solution that has the bleaching properties. So chlorine undergoes this proportionation in water. So the half equation is Cl2 plus 2H2O give HCl plus HOCl. Teacher, how about using organic solvent? Not recommended. Not recommended. Okay, not recommended. So HOCl is the active ingredient in the bleach, okay? Or HOCl is the bleaching agent, okay? Okay, so that is for this. Okay, and then number 2, calculate the volume of 0.0100 mole of sodium hydroxide solution needed to neutralize a solution containing 1.0 times 10 power negative 3 mole of the chlorine. So now, if you notice carefully, 1 mole of the chlorine in here, you produces 2 types of acid, HCl and also HOCl. So when you react with sodium hydroxide, you are reacting with both HCl and also HOCl. So the stoichiometry is 1 to 2. So since 1 Cl form 2 mole of acid, therefore mole of acid in the chlorine is MV, or 1.0 is 10 power of 3 mole, negative 3 not 3 negative 3 typing error. Negative 3 I accidentally lack of 1 negative, so it's negative 3 Okay. And then you use volume is equals to mole over 1000, so it's negative 3 Mole divided by 0.1, which is the concentration over 1000. So press your calculator, is 200 volume. Okay. Okay, so teacher, is iodine radioactive substance? Iodine can be radioactive. Can I ask this equation, we need to put reversible or irreversible? Irreversible. You are specifically which part? Is every OCl is a bleaching agent? Yeah. Why not? Please be specific which equation. Because if you are saying every equation, then not every equation are reversible. No. Usually we put a reversible equation on standard electrode potential. Standard electrode potential. Okay, Ken? Okay, so with that, we finish all the equations in here. So is there any questions that you want to ask? Because I finished already. Okay, I finished already. Okay, Q&A session. Okay. This one is one way, not reversible. This one is one way. This one is one way. Okay. Is incomplete fill or partial fill? Partial. Nowadays they say partial fill. Nowadays they use the word partial fill. Okay, partial fill. What else? This set of the question, I don't have D block elements question. You should also have a look at the D block elements. Teacher, is H2 plus Br2 reversible? No, it's one way. With heating 200 degrees Celsius. Yeah, partially filled. I know. In my books, I write incomplete, but it's partial fill. They say that it's more appropriate. Even if you look at the Tan In Tun's book, Tan In Tun's book, this Raymond Chang's book. Can I show you for a while? Sorry. Give me 1 minute. I double check with you. Actually, even in this Raymond Chang's books, the way of how they define transition element is like this. Let me see. Can you give me 1 moment? Incomplete transition incomplete field. Okay, they use the word incomplete field for Raymond Chang's one. Sorry. Okay. This is based on the Raymond Chang. Teacher high chance. Don't know. It's reversible if I just use reversible. Okay. Yes. Okay. Okay. So, teacher, for electrochemistry, when explaining the shifting of equilibrium, must the equation have reversible? Yes, usually it's like that. Okay. For thermal stability of G2 anion ascending of CO2 minus NO3 OH minus, is that how you explain if asked in essay question? It's depending on the situation, my dear. I cannot say for sure. I cannot say for sure. Okay, you see, thermal decomposition. Wait, Okay, so I asked ChatGPT to help me to check Okay, so this is what ChatGPT give me. Yeah, wait. Okay, I give you this. So magnesium hydroxide is 332, magnesium carbonate is 350, magnesium nitrate is 330. So that's why I said it depends on the compound, not necessarily it's like that. So in this case, you can see that it is the nitrate which is the lowest. Okay. No, I mean, at least they find from the internet one. So I'm not 100% sure saying that it is always correct. Okay. But what like don't be bothered too much about this anion part. I know it only come out like once in a very very long while only, and it is out of the syllabus. So sometimes don't be too bothered about it. I'm so sorry to say this. So if we meet again, quick question here. If question 4 is objective, can I use cathode anode formula to find whether it is spontaneous or not? I should stick to what we learned. If question number 4, oh, okay, can we use anode cathode? No, don't use E cathode minus E anode. Cannot. Because in spontaneity, it's not about cathode anode anymore. No. If you use cathode anode, definitely all anode value is going to be positive. Okay, so you don't use anode cathode. Instead of using anode cathode, you use the spontaneity of chemical reactions. You use the spontaneity of a chemical reaction in here. This one, in this case, you use the spontaneity. You have to know which one is your reactants in here. Okay. Okay, one or more stable ion, more than one stable ion. More than one stable. More than one stable. Is hydrolysis? Yes, hydrolysis is reversible. Hydrolysis is reversible. Chlorine and water is reversible in textbook. Why? Don't know. Don't ask me. I'm so sorry to give you this response. Wait. Sorry. Okay. Give me 1 minute. Sorry. Mr. Chu find out for you. I can, Mr. Chu sometimes can be very bad. I don't know. Don't ask me. Supposedly, I cannot say like that. I try my best to find out for you. wait. Tomate. Give me one more. I'm now looking at this Raymond Chang's books so that I can give you a very satisfactory answer. My main reference is definitely Raymond Chang's books in here. So all my equations are based on what equations in here. Okay. Wait, I think I'm almost there already. Give me a moment. Sorry, give me a moment. They didn't write. One way. It's one way. I confirm for you already. It's one way. It's one way reaction. Okay. This one is one way reaction. You can read at the Tan Yin Dun. You can read at the Tan Yin Dun. You can refer to the Raymond Chang's book. Okay. Okay, Ti4 plus valence electron is 3. We don't put 3d0. There is no 3d0. Just put 3s2, 3p6. Just put 3s2, 3p6. Okay. Is the answer 12 is A? 12 is A. Twelve is donkey, not A. Boron, not beryllium, boron. Okay. Any else? Okay, so I guess there's no more question else. That is all. Okay, wait. Some more, wait. So Cl2 is a hydrolysis process. Actually, yes, Cl2 and H2 is a hydrolysis. So sometimes it is indeed a type of hydrolysis. Yes, I wouldn't deny that. It is indeed a type, but usually we don't call it as hydrolysis. We say that it is disproportionate in water. Okay. Hey, hold on. Hey, yeah. Number 12 is A. Accept. Yeah. Number 12 is A. Thank you very much. Number 12 is A. Yes, you're right. 12 is A. D is a true statement. Yes. Number 12 is A. Thank you. Mr. Chu very clumsy. Thank you very much for helping. Number 12 is A. Thank you so much, my dear. Thank you very much. Yes, you're right. Thank you. Mr. Chu is like that sometimes. Okay, thank you very much for helping. Okay. No lah, not. Don't think of it as a hydrolysis. It is just a disproportionation. Okay. It's more to disproportionation, not really hydrolysis. That's why I said I wouldn't say it's wrong, but I never say that it's correct. Okay, so I guess that is all for our talks today. So wish you all the best for your exam next week. You can do it one since a lot of you already very good already. Okay, so hope for the best and I pray for your success. And I'll see you all in the semester 3 when you have the chance. How to study effectively in 1 week, Adama? Do look at as many past questions as you can. That's what I can say. Okay, so all the best to all of you. Okay, so I guess that is all for our talk today. It's interesting to share a lot of knowledge with all of you. And good luck. And I'll see you all in Sem 3 talk. Okay, everybody. Goodbye. Sayonara. Goodbye. Enjoy. Okay, welcome everyone.